So is this concept understood? So there is one thing we forgot to do. What is this then? By how much the floor is raised is called shift. What is the shift? Shift is B minus D. How much is the shift by which the floor is raised? Huh? That is the real depth minus apparent depth. So how do you calculate it? D minus D by mu n. Okay. This means the floor x is equal to 1 minus. So you may get a question on calculating shift. That's why how much it is shifting, right? So just stay here. What is the increase? That will be shift. Okay. So there is one more application. Check in your book what other applications are there. I am following Selena. See if there are more applications in the other publication. Actually, one more apparent bending of a thing underwater. Second application is apparent bending. of a stick underwater. So what do you observe that when a rod or a stick is inserted inside water? Does the shape change? The appears bend, right? Can you draw the ray diagram for it? How will it bend? Let us say you have inserted a stick inside like this. So how the stick will appear? Will it appear like this or like this? How will it bend? Upward or downward? After inserting inside water? Downward. Okay, draw a ray diagram. Show me. Let's say the observer is here. Observer is outside. Where is observer in the wearer medium? Is inserted inside water. Complete the ray diagram. What is different here? This is just like the case of bottom of the swimming pool. Now imagine this point as P. Okay, let's say this point is P. So take two rays coming out. This will go here. Correct? And the other, you may take slightly here. Where will it meet? It meets here. So this B now becomes B dash. Likewise for every point. So this will be ending like this. Understood? So the stick will bend towards. First point P will be raised up. So this will be P dash. Okay, just take two rays, one comes out of the water sheet to air of medium. Go away from the normal. Take slightly bigger diagram, then you'll be able to go. Everyone understood? This is nothing but point P is raised to P dash. So stick will bend upwards. Yeah. So we take just a reference point. Likewise, it will happen for every point. Just take the top. Is it clear or how we have drawn this? It's complex question take up. Where you may ask to draw the ray diagram for a stick which is partly under water and partly outside. These are the applications of various situations. This we already discussed. Observer in the denser medium. Okay, looking at objects outside. Okay, this we have already discussed. If the pen had asked then it was entered here also above. Say that again, say that again. If the pen had eyes, pen. If the pen had eyes, that we are above the second. Are you talking to yourself or to me? Huh? Is this how you meet me after the class? I'll clear your doubt. Okay. Next is some consequences of the refraction of light. So there are some 7 consequences. Now you can open your book. Everybody has Selena, at least one Selena per desk. No Selena per desk. Okay, let me see if it is given in the. What are the discussion? Applications of refraction of light. This is the last topic we have. That's why it was dealing actually. There are some consequences. Okay, hear me out. Some more consequences of refraction of light. Like twinkling of stars. Yes. क्या हुआ? क्या हुआ? हाँ? Okay. Twinkling of stars. Second is why twinkling of stars take place? Is it like star switches on and switches off like an electric bulb? Is it a luminous body? Yes. Then why it appears twinkling? Due to refraction of light. We'll discuss this. Twinkling of star takes place due to atmospheric refraction. Then what else? Early sunrise and delayed sunset. Early sunrise and delayed sunset. These are some more consequences of refraction of light. Where is the refraction taking place? When the light from star is entering the atmosphere. Is atmosphere a denser medium with respect to space? It is. When the light from star enters, what is the shift in the apparent position of the star? Up. Where is the observer? Let us say the observer is here. This is Earth. And this is Earth's atmosphere. Right? This is atmosphere. So if there is a star, let us say there is an observer here. When the observer is observing the light coming from star, it bends towards the observer. Atmosphere is denser, but the density of atmosphere is not fixed. The upper layers are less dense, and the layers closer to the surface of Earth is more. So it is not single bending. Continuously it bends like a top. Okay? क्योंकि यहाँ पे density कम है, so it bends like a top. So where is the apparent shift? This is the shift in the position of the star. But again, this is not a fixed, it is a dynamic medium. It is not like prism. Prism is a fixed medium, right? But this density keeps varying because atmosphere is a dynamic medium. Sometimes it increases, sometimes it decreases. So this apparent shift goes up and down. Okay? So let us say the observer was fixed. This gaze was fixed in one direction. And suddenly there is a shift in the position of star, depending upon variation of atmospheric density. So therefore, you are fixed in one direction and the star goes up. So it appears to you as it has disappeared. And again it comes back. So this constant appearance and disappearance due to the shift in the apparent position gives you the impression of twinkling of stars. This is what happens. Same thing happens during sunrise. If you see the horizon, this is the horizon. So anything below the horizon, you should not see, right? You will see anything which is above the surface of Earth. Now, due to refraction, let us say if sun is below the horizon, sun is actually not risen. It is still below the horizon. So what happens? The sun ray, when it hits the point of incidence on atmosphere, then instead of going like this, it appears, it bends in the denser medium, and therefore observer feels the sun to be here. This is early sunrise. The sun is still below the horizon, but due to atmospheric refraction, there is an apparent shift in its position. So there is a delay of 2 minutes. Actual sunrise that you see for the first time, okay, it's 2 minutes early. Then slowly it comes up. Likewise, at the sunset, the sun is already set, but you continue to see. That is delayed sunset. What's the reason? Atmospheric refraction. Is it understood? What is atmospheric refraction? What is atmospheric refraction? Go ahead. Listen. हिंदी में बोलो ना, whatever मुझे तो ऐसे बोलना है रिफ्रैक्शन होता क्यों ड्यू टू चेंज इन ऑप्टिकल डेंसिटी अभी मैक्सिमम डिस्टेंस किसमें आ रहा है स्पेस में तो ऑप्टिकल डेंसिटी है क्या कुछ है ही so when it enters the atmosphere light rays entering into a optically denser medium कौन सा बात चेंज है लेकिन ये जो denser medium है atmosphere light is created it doesn't have uniform density from the top layer of the atmosphere till the Earth's surface. The upper layer of the atmosphere is less dense as the light reaches closer. So the bending is not just once; it happens continuously. That's why it is a curve now. It is not a straight line. You see, it is a curve. So curve होने के बाद क्या होगा? The last direction was here. So what is the apparent shift? This observer feels that light is coming in this direction. So he feels the sun is here, but actually it is not. So these are the consequences of refraction of light. Understood? Same with star. Now again, why sun does not appear twinkling now? Star appears twinkling. Because sun is much closer. It's not like a point source like star. Star is much far away. So point shift हो गया, so you can feel that there is a shift. But every point inside sun can be considered as point source, right? तो यहाँ पे कोई पॉइंट था, if it shifts up, नीचे वाला ऊपर आएगा, तो नीचे वाला पॉइंट है उसको नलीफाई कर सकते हैं. So you don't see twinkling impression for in case of sun or moon or any near planet. They don't have a twinkling field because they are extended source of light. They are not point source. Okay, so there may be questions sometimes because it is there in Selena. No. Is it a doubt? Don't do that. Third is coin. You'll miss the point. Coin kept inside the vessel is not visible when seen from just below the edge of the vessel. Right? What am I trying to say? Let us say you have a it holds tea. Okay. Inside, if you have a coin, right? So imagine you have kept a coin inside the cup and you can see it. Right? What am I saying? You have kept a coin at the base of empty cup and it is visible to you. Now you are raising it up. You raise it till a height so that the coin is not visible to you. The brim of the cup is blocking the view. Okay? So in that position, what did I say? You have a cup with a coin which is visible to you. Now you have raised it. Now the coin is invisible. At this position, you start filling water. Okay? At that position, start filling water. Now you will see that the coin is visible to you. You can do this experiment today. So why it has happened? The coin से जो लाइट रे आ रहा है, that is the normal. ठीक है? जैसे ही वो एयर में आया, मेरी तरफ मुड़ गया. ठीक है? Bending away from the norm. Now you are able to see the point. So these are some beautiful experiments given here, and these are very, very interesting. Some of it you can do at your home. So explains. This is due to refraction of light. What is the path of light from denser to rarer? Okay, उसमें लिख गया है. Then fourth, the print appears to be raised when a glass slab is placed over it. Suppose you keep a glass slab, then now look at it. You will see the difference. If you see the text directly and through the glass slab, the text will be raised. Have you observed it? इसमें होता है ये बहुत पतला है, देखने से नहीं एक चाहिए. किसी को मोटा चश्मा है क्या? प्रत्युष रख के देख, टेक्स्ट ऊपर आ रहा है. आ रहा है ऊपर. ठीक है, you can try that. If you have any paper weight which is transparent, okay? If you have paper weight which is transparent, you can keep it here or keep a glass. Glass has a thick base. You will see the difference. It will be raised. So on and so forth. A person's leg appears to be short when standing in a tank. Right? Anybody enters inside the tank, the leg becomes short. That is also consequence of refraction of light. All right, let's move on to the next topic. Now we move on to the last topic, which is critical angle and total internal reflection. Okay, for this chapter. Let's study that. Critical angle. And total. The last concept to be understood in this chapter. Let us first understand what is critical angle. So far, Most of the examples we have seen, the light was traveling from rarer to denser medium. Now we will study the behavior of light when it travels from denser to rarer. Okay, so denser to rarer medium. Let's see. So let us say this is the denser medium, glass. Denser medium. Okay, and this is air, which is rarer medium. Let us say you have a source of light here, S. In this case, will there be any deviation? No. So when the light is traveling from denser to rarer medium, and when it is incident along normal, there will be no deviation. Now, let us study what happens when you increase the angle of incidence. What will happen here? Will there be deviation? Yes. It will go away. There will be further deviation. What is the difference now? This is R1, this is R2. So what are you observing? R is always greater than angle of incidence. Whenever light travels from, let me explain to myself. Whenever light travels from denser to rarer medium, so what happens? The angle of refraction is always greater than angle of incidence. Okay. So there will be a situation. There will be a certain angle of incidence for which the angle of refraction will become 90 degrees. Correct? You see the pattern? The angle of refraction is increasing. So for a certain angle of incidence, the angle of refraction will become 90 degrees. For a certain angle of incidence, the angle of refraction will become 90 degrees and the refracted ray will graze the refracting surface. Okay. So this angle has got a special name. It is called critical angle. What is it called? Critical angle. Okay. So critical angle, it is C or IC. So what is critical angle? Critical angle is angle of incidence in the denser medium for which the angle of refraction in the rarer medium becomes 90 degrees. Okay, what is critical angle? It is the angle of incidence in the denser medium for which the angle of refraction in the rarer medium becomes 90 degrees. That is critical angle. So critical angle is light travels from denser to rarer medium. The angle of incidence to denser medium. Which not refraction. The Where are we? Is it is small. No, critical. Yeah, basically critical angle is the angle of incidence in the denser medium. Always the angle of refraction in the rarer medium is 90. Yes, sir, this is yes, it is different for different medium. So for diamond it is 24 degrees, right? For water it is 42, like that. So every denser medium will have a different critical angle. 24 is the smallest diamond. Diamond is the hardest, yes, you can say that. That's why diamond glitters. So once the light enters inside diamond, okay, hold on. We need this concept to understand. So critical angle understood. Now, what if the angle of incidence is increased further? In this case, I is greater than P. What is the angle of incidence in this case? Greater than critical angle. And what is the pattern? R has to be greater than I. So now it has no choice, right? It will be totally internally reflected. Okay. What is happening here is total internal reflection. I is greater when the angle of incidence, when the angle of incidence is greater than the critical angle in the denser medium. Now what happens? Now the ray is bounced back in the same medium. This is total internal reflection. So it begins to act like a mirror now, without any silver coating. Now this is different phenomenon. You didn't understand. Did you pay attention? Okay, pay again. Till C, till critical angle, what is the refractive angle of refraction? You got 90. So where else it can go now? What is happening? Angle of refraction is increasing with increasing angle of incidence. At C, it has reached the limit. What is greater than 90? It will be now in the medium. So it is bounced back in the same medium now. Whenever the angle of incidence is greater than critical angle. So now a different phenomenon is taking place, which is called as total internal reflection. Again, so what are the two conditions for total internal reflection to take place? Light has to travel from denser to rarer medium, and angle of incidence has to be greater than critical angle. And critical angle for a given medium is constant. We can determine the critical angle for a given medium, just like refractive index. Every medium has a well-defined refractive index. Likewise, every denser medium has a critical angle. Is that clear? Now we will derive how to determine the critical angle. Okay. So conditions for TIR. Conditions for total internal reflection. In refraction, now we have reflection. Okay. So don't be confused. This is a special condition when light has to travel from denser to rarer surface. The angle of incidence in the denser medium must be greater than critical angle. Critical angle. So what is the condition for total internal reflection? Two things. Light has to travel from answer to error area. And the angle of incidence has to be greater than critical. Equal to critical angle पर क्या होगा? It will still undergo refraction. The maximum angle of refraction called 90 degrees. Refracted ray is still in the error way at critical angle. What is the definition of critical angle? What is the pattern? See the rays before critical angle. The angle of refraction is going on increasing as we increase the angle of incidence. So there will be angle of incidence on which the refracted ray will graze the surface. So what is the angle of the refracted ray with now 90 degrees? That angle of incidence is called critical. अच्छा उससे भी ज्यादा बढ़ाया हमेशा क्या हो रहा है रिफ्रैक्शन इज increasing surface पे limit close to now it is bound back in the same period. So when the light is bouncing back in the same period, then it is not reflection, isn't it? So now what is taking place is total internal reflection. So wherever TIR is taking place, the tensile medium is now acting like a mirror. Yes, yes. It is. That is why we are calling it. When we say angle of refraction, and there is a pair of medium. So that's the limit of refraction. Critical angle is the limit of reflection. After that, it will increase the angle of incidence, and it will be TIR. Okay? Critical angle is the boundary condition. Is that clear? So now the diamond. Why do diamond glitter? Because it has a small critical angle. Now, if the one slide enters inside diamond, then when it hits diamond surface, so it is denser to air condition. And since the critical angle is very small, even at a small angle of incidence, it is internally reflected. Once the it starts glittering. Okay, yes, sir. So how to achieve glitter? By polishing the diamond. So it's a special technique which is taught. It is a specialized area. So diamond surface is cut and polished in such a way that maximum TIR takes place once the light enters diamond. Okay. So is this understood? So how to determine the critical angle? Right? Determination of critical angle for various mediums. That's next. Have you noted this down? Is it noted? Calculate the critical angle. We just need to know the refractive index of the medium. Okay. How to calculate refractive index? We have seen experiment. Okay. So let's see here. So imagine a ray is traveling from denser to rarer medium. Okay. So what is the direction of ray? It is from denser to rarer medium. This is denser medium. Last. Okay. So apply by Snell's law at P. At O. What do we get? Sin C divided by sin R is equal to mu AG. What do we get? So we'll write this as medium, right? Medium. Medium. Okay. Therefore, sin C on sin 90 is equal to 1 by 2 MA. Therefore, sin C by 1, sin 90 is 1 equal to 1 by given. Right? Critical angle is equal to so what is the relation between critical angle and refractive index? Inverse relation. Higher the refractive index, smaller is critical angle. Okay. So to find critical angle, we just need to know the absolute refractive index. Yeah. तो सबसे कम critical angle किसका होगा? इसका refractive index सबसे कम होगा. Diameter, there is a table given in your book. Exercise. So there is a table in the book which has critical angle and refractive index given for various mediums. So for water, the critical angle is 49 degrees. What do we have? Water के लिए कितना है? 1.33. Critical angle is 49 degrees. Glass is 1.5. Critical angle is 42 degrees. Diameter 2.41. This is roughly 25 degrees. Okay. Okay. So it's for diamond it is 24.5 degrees, which is approximately taken as 25 degrees. These are all approximate values. Okay. The values that you see are approximate. These are not exact values. 24 dot something, so that is 25, that way. Clear? So since the critical angle depends on refractive index, what are the factors? It will depend on refractive index and what else? Temperature, anything that affects the refractive index. Okay. So that's it. Now application of TIR in prism. Now we'll study the applications of total internal reflection in prisms. First use is the first use. We will obtain the deviation of 90 degree by using 45 degree, 90 degree, 45 degree prism. So therefore, you have a prism like this. So you have a prism like this. Can we discuss the application or you're writing still? Everybody done writing? Okay, so we will achieve deviation of 90 degree using 45 degree, 90 degree, 45 degree. तो ये 45 दो एंगल है और ये 90 degree. So what we'll do is, let us say we have some object here, maybe. So this is the ray coming from the top of the object. It hits the prism space AB like this normally. So what will happen? Will it enter straight or deviate? Straight, because it is incident along normal. So it will enter straight. Okay. Now what is the angle of incidence on face AC? Huh? What is the angle of incidence on face AC? 45. Where is 45? J 45. Is 45? That is angle of incidence. Where is angle of incidence? We draw a normal here. What is this angle? 45. Correct? Has to be 45 because so 45. And this is 45, this is 90. So this is 45. This also has to be 45. So this is 90. So is 45 greater than critical angle for glass? No. What is critical angle for glass? 42. Is 45 greater than 42? Yes. So क्या होगा वहां पे? TIR होगा? तो TIR होगा. So this will be reflected by 45 degree. This is 45 degree. So it is incident on face BC By what angle? 0. It will come out. Correct? Likewise, the lower ray will also pass like this. What is happening here is TIR and TIR. Here. At this point also TIR. Okay, so what are we getting here? What is the angle of deviation between incident and convergent ray? So extend it. This is 90 degrees. What is the angle of deviation? Angle of deviation is always measured with respect to input ray, original. Okay. What is the angle of deviation? 90 degrees. Okay. So where is it used? It is used in making periscopes. Is too cold? Which one? Both. Both ACs to be turned off. Which one? कौन सा है वो बीच वाला है कौन सा है? तू यहाँ पढ़ने आता है कि हवा खाने आता है? एसी बंद करो तो मैच चलाओ। इसको डाउन है। This also off. Will start suffocating. Jacket पहनने के बाद। Don't think about it. 5 minutes. Wait for 5 minutes. You're not going to freeze or melt. Don't think about it. जितना तुमको पंखे और एसी का ध्यान है थोड़ा सा यहाँ ले लेते ध्यान। ये समझ में आया? कहाँ पे यूज होगा ये? इन बिल्डिंग पेरिस्कोप्स। अब पेरिस्कोप क्या होता है? तुमने मिरर से बनाया हुआ पेरिस्कोप है ना? तो मिरर से कैसे किया था? Two mirrors inclined at 45 degree. Okay. So in submarines, you can use periscope to see outer objects. While you are underwater, the captain can see objects outside, threats outside, right? So mirror वाला जो periscope है, it is based on reflection of light, where the reflected ray is not fully reflected. Some of it is absorbed. But in case of total internal reflection, right? TIR is 100% reflection. So the image quality obtained by using prism is much better than it is with respect to mirror. Okay, so obviously periscopes that are using reflecting prism are more costly. Okay, na? So we'll use two prisms like this to obtain the same thing. So where will be the lower prism? How will you use prism to obtain this kind of reflection? Now what you'll do here? Here you will keep the prism like this. This way. Understood? How the prisms will be used for making periscope? ठीक है? है ना? तो deviation by 90 degree. So you'll use multiple prisms to obtain a periscope. Likewise, we have different application. Next is to deviate a ray by 180 degree. That is used in constructing binoculars. Okay. So let's see second application. So what you have to understand is it is taking place because of TIR. Deviation by 90 degree is used in constructing periscopes. Okay. अब second देखते हैं second one. Deviation by 180 degree. Same. 45, 90, 45. So how do we achieve it? 180-degree deviation. Now the prism is kept like this. Now the ray is inputted like this. Okay. So now you have A, B, C. The ray is incident normally on face AC now. So if it is normal, then obviously it will go straight. At this point, the angle of incidence is greater than 45, greater than critical angle. And our prism is actually we are using glass prism. In glass prism. Application of TIR in glass prism. So glass का critical angle 42 है. यहाँ पे क्या हो गया 45. ये भी TIR होगा. यहाँ पे भी 45 मिल रहा है. So by geometry, you are able to figure out that this is 45. हर जगह critical angle क्या मिल रहा है? 45. अंदर के फेस पे. ठीक है? तो ऐसे हो गया. Let's say you have AB. और एक रे ले लो. So these radar diagrams are asked to draw. So यहाँ पे सीख लो थोड़ा. ठीक है? Actually है simple. Just have to remember the sequence where the total internal reflection is taking place. ठीक है? तो अभी कैसा दिखेगा तुम्हारा ऑब्जेक्ट? यहाँ पे कैसे दिखेगा? ये. So where is it used? Used in constructing binoculars. ठीक है ना? Binoculars में यूज होगा. कैसे यूज होगा देखो. तो रिमोट ऑब्जेक्ट से this is I have shown for one eye. ऐसे दो प्रिज्म यूज करेंगे, now it is reflecting, ठीक है? This is how it will be used. So what is the deviation now? What is the deviation achieved? 180 degree. Input ray upward, output ray downward. है ना? What is the angle of deviation here? 180 degree. क्योंकि ऐसे है और ऐसे 180 होगी. Angle of deviation is always with respect to input ray. कैसे हो 180 डिग्री का deviation? Angle of deviation किसके किसके बीच में होगा? इनपुट और आउटपुट के सिंपल रख. एंगल ऑफ डेविएशन किसके किसके बीच में होता है? इनपुट और आउटपुट रेस में. इनपुट कैसे आ रहा है? ऊपर. आउटपुट कैसे? एक से. दोनों के बीच में क्या हो? 180. तुम्हें समझ में आया? व्हाट इज डेविएशन? एंगल बिटवीन इनपुट एंड आउटपुट रेस. तो इनपुट कैसे जा रहा है? ये डायरेक्शन में. आउटपुट कैसे आ रहा है? ऑपोजिट डायरेक्शन में. क्या हो? 180. Next application. Next is no deviation, only direct the inverted image. Next application is direct the inverted image. So first draw these two diagrams, then I discuss the third case. And here there will be no deviation, without deviation. Draw the diagrams. अरे ये वाला नहीं बनाओगे. Don't draw this. Only draw this. This I have drawn for explaining it. You only draw the prism diagram. Okay, do not draw this. You have to only draw prism diagram to understand how the deviation is taking place. Application would be thousands of applications. Yes, so you have to think of a orientation. There are different deviations. Now we will see the application when there is no deviation, just flipping of the image. So final image, let's say your God is upward, downward. Let's say you have telescope. Okay? So telescope का image कैसे आएगा? Real inverted. Now you use a prism. But will invert that image so that it becomes easy for you to comprehend it. ठीक है? So direct the inverted image without deviation. उसमें क्या करेंगे? So this is 90. Sir. और सर आ रहा है आवाज तो धीरे धीरे पहले उठ आप मेरे को बस बोलना था अच्छे भाई यहाँ एसी चालू नहीं है एक में होगा नहीं होगा चालू लगा ऐसे देखो अभी क्या है ये यहाँ पे the image is AB आउटपुट क्या हो रहा है डिविएशन है इनपुट में और आउटपुट में डिविएशन है क्या इनपुट कौन से डायरेक्शन में ऐसे आउटपुट कैसे सेम डायरेक्शन ठीक है ना इनपुट आउटपुट में कोई डिविएशन नहीं है अब TIR कहाँ पे हो रहा है ये ठीक है Okay. What is taking place here? Refraction. What is taking place here? Refraction. Bottom surface पे क्या हो रहा है? TIR. Because it is satisfying the ये कितना है? 45 है. ठीक है. ये 90. Sorry. ये तो ना ठीक है 90 नहीं है ठीक है. ये चलते हैं. ये क्या होगा? This will be greater than 42. यहाँ पे greater than 42 मिलेगा. ठीक है. This is what it is. देखो ये greater than 90 हुआ ना ये पूरा ये क्या होना चाहिए less than 45 ये क्या होगा greater than 45 मतलब 42 से तो बड़ा हो गया ये greater than 90 है normal 90 है normal plus something ये एंगल क्या होगा less than 45 होगा ये एंगल क्या होगा greater than 45 so it is satisfying TIR condition greater than 90 बेटा नॉर्मल 90 होता है ना नॉर्मल से ज्यादा है ना कौन से चाचा से पढ़ के आए हो पढ़ के ही नहीं है चाचा की गलती नहीं है बुला के टोटल टाइम पास और कौन सा है ये वाला तुम लोग को चाहिए तुम लोग को तुम्हें चाहिए AC बंद कर दिया कि चालू की ओके तो इसमें डिविएशन है क्या डिविएशन इसके अंदर यहाँ पे क्या हो रहा है तो ये ठीक है क्या डायरेक्ट इन्वर्टेड इमेज एक्चुअली हमको यहाँ पे ऐसा मिला था उल्टा वो वहां पे जाके सीधा हो उसको उल्टा कर ये क्या होगा जो टेलीस्कोप की फाइनल इमेज थी वो कैसे थी ऐसे तो इसके बाद क्या हो जाएगा वो इन्वर्ट हो जाएगा ठीक है तो व्हाट इज द एप्लीकेशन हियर वी आर इरेक्टिंग द इन्वर्टेड इमेज इनपुट क्या दे रहे हैं इन्वर्टेड इमेज व्हाट इज द आउटपुट नाउ अपराइट ओके so this is the application of 45 90 degrees 45% to achieve only inversion without any deviation There is no deviation because both input and output are in the same direction. Okay. Next is total internal reflection through a prism layer. Which angle is? Okay. Next application is deviation by 60 degree using equilateral prism. ठीक है equilateral prism. अब देखो now we are changing the prism. It is no more 90 45 90. Now we are going to use a different prism. कैसा prism? तीनों एंगल 60 डिग्री. क्या डिविएशन चाहिए हमें? 60 डिग्री. तो भी हमने देखा अलग अलग डिविएशन या नो डिविएशन के बहुत सारे एप्लीकेशंस बनते हैं. ठीक है. तो अभी we have to achieve deviation of 60 degree. क्या एप्लीकेशन है हमें नहीं पता. तो but now we have to know how to obtain a deviation of 60 degree by using equilateral prism. तो देखो ठीक है. So be the input ray is like this. Input ray is like this. It is incident on face AB. कैसा incident है? Along the normal. किताब लेके इधर बैठ. जल्दी आ. तुरंत फटाक से कान पकड़ के लाऊंगा नहीं. जल्दी. तू 2 बेंच पीछे जा. पीछे जा. बैग के पीछे जो बैग है ना उसके पीछे और उसके पीछे बैठ. तो ये इनपुट रे हमको क्या चाहिए? डिविएशन बाय 60 डिग्री. अब देखो ये 60 है ये 90 है तो ये क्या बना 30. अब यहाँ पे बनाओ नॉर्मल. तो ये 90 माइनस 30 कितना बचा 60. मतलब एंगल ऑफ इंसिडेंस क्या बना एसी पे एंगल ऑफ इंसिडेंस क्या है 60 डिग्री. तो रिफ्रैक्ट होगा कि रिफ्लेक्ट होगा?
सर आपने 90 माइनस 30 कैसे किया?
देख नहीं रहा क्या? देखो ये 60 है ये 90 है. एंगल सम प्रॉपर्टी 60 प्लस 90 कितना हुआ 150. तो लास्ट एंगल कितना होना चाहिए 30. एंगल सम प्रॉपर्टी लग रहा है.
मतलब आपने इस साइड से
ये ट्रायंगल के लिए किया मैंने 30. तो एंगल ऑफ इंसिडेंस नॉर्मल के साथ कितना बनेगा? ये फेस पे नॉर्मल 90 है 90 माइनस 30 कितना बचा 60. तो एंगल ऑफ इंसिडेंस क्या बना इस पॉइंट पे 60. तो टीआईआर होगा कि रिफ्रैक्शन होगा? यहाँ पे क्या होगा? ये भी ग्लास प्रिज्म ही है ना. टीआईआर होगा. क्यों? क्योंकि एंगल 60 है 42 से बड़ा है. टीआईआर होगा. यहाँ पे तुम 60 बनाओ ये भी 60 होगा. अब ये 30 हो जाएगा. इसका मतलब ये 90 होना पड़ेगा. 90 मतलब इस पे परपेंडिकुलर आ गया. मतलब ये सीधे बाहर आएगा. ठीक है, सीधे बाहर है। अब एंगल ऑफ डिविएशन कितना बनेगा, देखो एंगल ऑफ डिविएशन क्या है, इसको एक्सटेंड करो, ये 30 है तो ये भी 30 होगा। सो व्हाट इज द टोटल एंगल ऑफ डिविएशन, 60, 30 प्लस 30, समझ आया? टोटल एंगल ऑफ डिविएशन क्या हुआ, 60। गुड, पीछे जाओ। और पीछे, एकदम पीछे, उसके भी पीछे बैठ। कितना हो गया टोटल, 60 हुआ कि नहीं डेविएशन, ये ओरिजिनल डायरेक्शन, ये फाइनल आउटपुट रे, तो दोनों 30 प्लस 30, क्योंकि ये वर्टिकली अपोजिट है ना, ये भी 30 होगा। पूरा ज्योमेट्री है, नॉर्मल और राइट एंगल प्रिज्म का कॉन्सेप्ट लगा रहे हैं, एंगल सम प्रॉपर्टी यूज की है, वर्टिकल ऑपोजिट और एंगल सम प्रॉपर्टी से तुम्हारा एंगल निकल जाएगा, तो मिल गया डिविजन बाय 60। तो इसमें खाली कैसा क्वेश्चन पूछता है, ड्रॉ द रे डायग्राम यूजिंग इक्विलेटरल प्रिज्म टू ऑब्टेन डिविएशन बाय 60 डिग्री, तो ये तुम्हें आना चाहिए। डाउट है?
ये पूछ रहा था सर,
ऐसा है,
मैंने कुछ पूछा कि नहीं?
सुनो सुनो, हिंदी समझ में आती है? हाँ, एक दूसरे को समझाना बंद करो, डाउट है तो मेरे से पूछो, कई बार बोल चुका हूँ, बात समझ में आ रही? डिविएशन कैसे हो 60 डिग्री, समझ में आया कि नहीं, बता कैसे हो, कैसे एक्सप्लेन कर, एग्जाम में मैं लिखने वाला हूँ जाके, एक्सप्लेन नहीं करना है यहाँ पे, खाली डायग्राम बनाना है। यहाँ हिंदी में बोलो ना, सर ये इनपुट रे है, ये 90 है तो सीधे जाएगा, डिविएशन नहीं होगा, तो यहाँ पे हिट करेगा तो एंगल ऑफ इंसिडेंस 60 डिग्री बन रहा है, तो रिफ्लेक्ट होगा, तो एंगल, लॉ ऑफ रिफ्लेक्शन क्या है, इंसिडेंस और रिफ्लेक्टेड रे क्या होगा, सेम एंगल, ये 60 है तो ये 60 बनेगी। अभी नॉर्मल है तो 90 में से 60 निकल गया तो क्या बचा, 30, ये 30 है, ये नॉन है 60, तो 30 प्लस 60 90, तो बैलेंस लास्ट एंगल 90, इतना ही तो है, और क्या है, ठीक। तो अभी एंगल ऑफ डिविएशन इसका और ओरिजिनल डायरेक्शन में कितना है, तो इस पॉइंट पे इसको एक्सटेंड करो, तो ये 30 था एंगल, अंदर वाला एंगल, तो वर्टिकली अपोजिट इसको भी 30 बनाओ, तो ये 30 प्लस ये 30 क्या हो गया, 60, ठीक है, यही फॉलो करना। नेक्स्ट, टोटल इंटरनल रिफ्लेक्शन, अभी हमको एक अलग टाइप का प्रिज्म यूज करना है, कौन सा, 30 डिग्री, 90 डिग्री एंड 60 डिग्री, और डिविएशन कैसा चाहिए, लेस देन 60 चाहिए, ठीक है। इसके अलग अलग एप्लीकेशन होंगे, हमें अभी इसके एप्लीकेशन में नहीं आना। नाउ यू हैव टू ऑब्टेन द रे डायग्राम फॉर डिविएशन लेस देन 60 डिग्री, और उसके लिए कैसा प्रिज्म यूज करना है, क्या वो कुछ डाउट है, तो बगैर डाउट की बात कर रही है, डाउट है तो पूछो, ये समझ में आया, ये समझ में आया, हाँ या ना बोलो, अभी आवाज ही नहीं आ रही, अभी तो बहुत बतिया रही थी, ये समझ में आया क्या, बोलो हाँ। अब कैसे आया बताओ, बोलो, डांट नहीं रहा हूँ, बोल रहा हूँ। तुम लोग लॉस्ट क्यों हो जाते हो, फोकस करते नहीं हो और आपस में पूछ रहे हो, बताओ ना कैसे है, इनपुट रे से शुरू करो, अभी समझाया मैंने 2 बार, वेर इज द इंसिडेंट रे फॉलिंग ऑन फेस ए बी, उसके बाद क्या हो रहा है, इट इज एंटरिंग डेंसर मीडियम, विल इट डिविएट, व्हाई, कंडीशन फॉर नो डिविएशन दो ही होता है, एंगल ऑफ इंसिडेंस 0, तो डिविएशन नहीं होगा, यहाँ पे एंगल ऑफ इंसिडेंस क्या है, 0, तो स्ट्रेट जाएगी। नाउ इट इज हिटिंग फेस AC, व्हाट इज द एंगल ऑफ इंसिडेंस एट AC? कैसे पता चलेगा एंगल ऑफ इंसिडेंस की 60 है? देखो दो एंगल यहाँ पता है, ये 60 और ये 90, तो लास्ट एंगल क्या बना? 30, एंगल सम प्रॉपर्टी। तो बैलेंस क्या बनेगा? ये नॉर्मल है, 90 माइनस 30 क्या बचा? 60 मिल गया। तो अभी एंगल ऑफ इंसिडेंस 60 मिल गया, विच इज ग्रेटर देन क्रिटिकल एंगल, तो TIR होगा यहाँ पे। जब रिफ्लेक्शन होगा तो जितना एंगल ऑफ इंसिडेंस है वही तो एंगल ऑफ रिफ्लेक्शन है। तो अब ये एंगल 60 मिल गया, ठीक है, तो ये 60 मिला, तो ये बैलेंस एंगल क्या बनेगा? 90 माइनस 60, 30। अब उल्टा करना है, पहले यहाँ 30 मिला तो 60 हुआ, अब यहाँ 60 मिला लॉ ऑफ रिफ्लेक्शन से, तो मुझे ये 30 बैलेंस एंगल। अब ये 30 है और ये इक्विलेटरल का 60 है, तो लास्ट एंगल क्या बचा? ट्रायंगल का 90। तो 90 पे अगर नॉर्मल में आ रहा है तो एंगल ऑफ इंसिडेंस क्या बना इस पॉइंट पे? 0, तो डिविएशन नहीं होगा, ठीक है। तो ये फाइनल आउटपुट रहे। अब इसका डिविएशन विद रिस्पेक्ट टू दिस ये कैसे पता चलेगा? तो ये इसका ओरिजिनल डायरेक्शन ये था, इसका डायरेक्शन ये 30 डिग्री था, और ये भी 30 डिग्री अंदर, तो इसको एक्सटेंड किया तो वर्टिकल ऑपोजिट क्या बना? 30। ये 30 प्लस ये 30 कितना हुआ? तो डिविएशन कितना बना? यही तो चाहिए, ठीक है। खाली दो कॉन्सेप्ट यूज करना है अपने को, एंगल सम प्रॉपर्टी और वर्टिकल ऑपोजिट। और डिविएशन किसके किसके बीच का एंगल है? ओरिजिनल इंसिडेंट रे एंड फाइनल आउटपुट रे, फाइनल, ठीक है। अब नेक्स्ट केस हम डिस्कस करेंगे डिविएशन लेस देन 60 डिग्री, ठीक है। और उसके लिए व्हाट काइंड ऑफ प्रिज्म वी आर गोइंग टू यूज? 30, 90, 60, ठीक है। पहले अभी तक कितना यूज किया हमने? 45, 90, 45, उसमें तीन केसेस थे। फोर्थ केस में हमने क्या लिया? इक्विलेटरल। अभी फिफ्थ केस में क्या लेने वाले हैं? 30, 90, 60 डिग्री प्रिज्म। तो देखो फिफ्थ केस में we will use deviation less than 60 degree, less than 60 degree, using 30, 90, 60 degree prism, ठीक है। ये प्रिज्म कैसा होगा अभी? Will it be isosceles? ये इस टाइप का प्रिज्म होगा। This is 30, this is 90 and this is 60, ठीक है। So now we have a different prism. We want to obtain now deviation less than 60 degree. तो उसके लिए ABC. Now we will input the ray from base, मतलब ये साइड base BC, ठीक है। यहां से इनपुट किया, तो ये 60 है, ये 90 है, तो ये क्या हो जाएगा? 30। यहाँ नॉर्मल बनाओ, ये क्या बना? 60 बन गया। यहाँ पे 60 बनाओ,
ये भी सबसे
ठीक है, ये 60 हो गई। यहाँ नॉर्मल बनाओ, तो बताओ ये वाला एंगल क्या होगा? ये एंगल क्या होगा? व्हाट इज एंगल ऑफ इंसिडेंस? ये नॉर्मल है ना, नॉर्मल को अगर तुमने यहां तक एक्सटेंड कर दिया तो ये क्या है? 90। टोटल क्या है? यहां से मिलेगा एंगल? नहीं मिलेगा। ये हो गया तुम्हारा 60, ये क्या हो गया 60, ये कितना बचा 120, ये क्या था 30, ये क्या होगा 30, क्या होगा 30, तो एंगल ऑफ इंसिडेंस हो गया तुम्हारा 30, तो TIR होगा नहीं होगा। अब ये किधर जा रहा है डेंसर से रेयर में जा रहा है, तो ये होगा अवे फ्रॉम नॉर्मल, अवे फ्रॉम नॉर्मल, तो एंगल ऑफ रिफ्रैक्शन ये क्या होगा R इज ग्रेटर देन 30, ये क्या बनेगा लेस देन 30, लेस देन 60, ये तो चाहिए था अपने को, ये क्या बनेगा दिस एंगल इज लेस देन 60, क्योंकि टोटल 90 होना चाहिए ना नॉर्मल के साथ, तो अगर ये ग्रेटर देन 30 है तो ये लेस देन 60 होगा। और एंगल ऑफ डिविएशन किसके किसके बीच का एंगल है ओरिजिनल डायरेक्शन एंड फाइनल डायरेक्शन, तो ओरिजिनल का ये पैरेलल ले लो यहां से, तो BAB ओरिजिनल डायरेक्शन, so what is the angle of deviation less than 60, correct, समझ आया, so this is less than 60, why because angle of refraction is greater than 30, tensor से level में जाना, so balance angle has to be less than 60, understood, समझ आया, ये दिख रहा है क्या पीछे से तो दिखने का दिख रहा है, दिख रहा है यहाँ से, तो कैसे समझ आया, आगे चलिए बैठ क्या बैठ ऑफिस में देख के कैसे अरे क्या वहां मत चला चला आगे धीरे चल आगे चल बोल पहले देख आगे डायग्राम दिख नहीं रहा बोल रहे हैं समझ आ रहा है डिविएशन लेस देन 60 है बताओ कैसे, ये कौन सा ओरिजिनल रे ठीक है, ये 60 डिग्री है सीधे गया तो ये नॉर्मल 90 बनेगा, तो ये क्या बनेगा 30, अब यहाँ पे नॉर्मल बनाया तो नॉर्मल के साथ ये पूरा 90 है ना, 30 माइनस करेंगे तो क्या बना 60, तो एंगल ऑफ इंसिडेंस क्या बना ये पॉइंट पे 60 बनता है, मतलब यहाँ पे क्या होगा TIR, और तेरे को दिख रहा है क्या पीछे दिखा ना, कॉन्सेप्ट क्लियर है, तो यहाँ पे कितना हुआ अभी ये नॉर्मल से ये 60 है तो रिफ्लेक्टेड भी 60 होगा, टोटल 90 है तो ये 30 हो जाएगा, ठीक है ना, फिर यहाँ से इधर इंसिडेंट हुआ तो ये अब इस पॉइंट पे नॉर्मल बनेगा है ना, तो ये नॉर्मल बना तो ये 90 ये 30 था तो ये ट्रायंगल का ये 60 होगा, ये बैलेंस कितना हुआ लीनियर है ना 180 माइनस 60 120, ये 120 है और ये 30, ये 60 था तो ये 30 हो गया ना, ये कितना होगा ये भी 30 होना पड़ेगा, ये ट्रायंगल का ठीक है, तो एंगल ऑफ इंसिडेंस मिला मेरे को यहाँ पे 30, अब ये कहाँ जा रहा है रेयर में है ना, रेयर में अवे फ्रॉम नाउ, ये क्या होगा ग्रेटर देन 30, टोटल 90 है अगर ये ग्रेटर देन 30 है ये लेस देन 60 होना चाहिए, हाँ 30 प्लस 60 क्या हुआ 90 ना, तो 90 में अगर ये 30 होता तब ना ये 60 होता, लेकिन ये 30 से ज्यादा है मतलब समझिए 35 है, ये क्या बनेगा फिर 55, क्योंकि टोटल क्या आना चाहिए 90, ग्रेटर देन 30 हुआ तो ये लेस देन 60 होगा, तो फिर डिविएशन क्या बना ये फाइनल रे ओरिजिनल डायरेक्शन भी ये और ये पैरेलल है ना मतलब यही है डायरेक्शन, कितना हो लेस देन 60, ठीक है तो गुस्से में बोलता है ना तेरी आवाज ऐसी है मेरे जैसी गुस्से में, ठीक है बस बैठ जाओ, मृत्यु से दूर बैठ, वो तेरा दोस्त नहीं है वो दुश्मन है, सबको डिस्टर्ब करने के लिए आता है, सब सेक्रेटरी बनने को तैयार रहते हैं एक दूसरे के, कॉन्सेप्ट समझा क्या अभी, ठीक है चले प्रोसीड, ओके नेक्स्ट इज कुछ और पूछ रहा था क्या? मैं समझा नहीं तू क्या पूछ रहा है। नॉन ऑकरेंस ऑफ टोटल इंटरनल रिफ्लेक्शन। देखो अभी तक हमने जितने भी केसेस पढ़े हैं कहीं ना कहीं टीआईआर हुआ है हर केस का, ठीक है। नाउ विल सी द केस if the rays incident on a certain phase there is no TIR taking place, ठीक है। तो केसेस ऑफ नो TIR for the same prism, right? अब ये इसी का सब केस है, नो TIR in 30, 90, 60 degrees। उसके लिए क्या देखो, BC की बजाय इफ यू आर इनपुटिंग द रेस फ्रॉम AB एंड AC तो क्या होता है देखो, टाइम खत्म हो गया, ठीक है चलो नेक्स्ट।
Right.